Art thou pale for weariness of climbing heaven and gazing on the earth, wandering companionless among the stars that have a different birth, and ever changing like a joyless eye that finds no object worth its constancy? Percy Bysshe Shelley to the moon. On Monday, October 26, 2020, NASA announced an amazing result. It has discovered water molecules on the sunlit surface of the moon, the romantic satellite orbiting around the Earth. This discovery was made possible by the SOFIA telescope that observes our infrared solar system. But we already knew that water existed on the moon. So which is the amazing result that they were talking about? How will this discovery be useful for NASA's Artemis program? Follow me on this journey to try to answer this question and discuss the importance of this discovery, and to learn more about the moon that never ceases to amaze us after all this time. The SOFIA telescope found undoubted proof of water molecules presently trapped in the regolith structure of the sunlit lunar surface. This discovery is important for some reasons. 1. SOFIA has detected molecules, H2O, in Clavius crater, one of the largest craters visible from Earth, located in the moon's southern hemisphere, on the visible surface. The fact is that this time water was found on the sunlit surface. We already knew that cold, shadowed places near the lunar poles were able to host water, but without a thick atmosphere, water on the sunlit lunar surface should just be lost to space, said Dr. Casey I. Honeyball, a postdoctoral fellow at NASA's Goddard Space Flight Center in Greenbelt, Maryland. Yet somehow we're seeing it. Something is generating the water, and something must be trapping it there. 2. We are sending humans to the moon again. When we first went to the moon, it was 1969. Apollo 11 was the space mission that brought us to the moon on July 20th, 1969. We plan to establish a sustainable human presence on the moon by the end of the decade. All of this will happen under the Artemis mission. Water is a precious resource in deep space and a key ingredient of life as we know it. Could Artemis astronauts use this water as an accessible resource? This has to be determined. Also, since water molecules can be broken apart in their constituent hydrogen and oxygen atoms, we could use it in order to give the astronauts something to breathe. Hydrogen and oxygen can also be used as rocket propellant for trips to Earth, or maybe Mars and beyond. Most of all, the finding of water in the sunlit surface of the moon is something that has a logistical relevance. It will be easier for astronauts to pull out water since we can find it in less deep places. Also, if we plan to extract water from very deep craters, we would spend a lot of energy to keep the environment at an approximate temperature. Temperature in craters at lunar poles can reach 200 degrees Celsius. 3. This discovery reveals that water might be distributed across the lunar surface and not limited to some cold, shadowed places, such as deep craters at the lunar poles. But what is the SOFIA telescope and how does it work? On NASA's website, we can read, SOFIA, the Stratospheric Observatory for Infrared Astronomy, is a Boeing 747 SP aircraft modified to carry a 2.7-meter, 106-inch reflecting telescope with an effective diameter of 2.5 meters or 100 inches. SOFIA flies in the stratosphere at 38,000 to 45,000 feet, above 99% of Earth's infrared blocking atmosphere, allowing astronomers to study the solar system and beyond in ways that are not possible with ground-based telescopes. The observatory's mobility allows researchers to observe from almost anywhere in the world and enables studies of transient events that often take place over oceans where there are no telescopes. For example, astronomers on SOFIA studied eclipse-like events of Pluto, Saturn's moon Titan, and Kuiper Belt object MU-69. The next flyby target for NASA's New Horizons spacecraft to study the object's atmospheres and surroundings. SOFIA is designed to observe the infrared universe. Many objects in space emit almost all their energy at infrared wavelengths and are often invisible when observed with visible light. In other cases, celestial clouds of gas and dust block the light emitted by more distant objects, but infrared energy pierces through these clouds. In both cases, the only way to learn about these objects is to study the infrared light they emit. Unlike space-based telescopes, SOFIA lands after each flight, so its instruments can be exchanged, serviced, or upgraded to harness new technologies. Because these new instruments can be tested and adjusted, SOFIA can explore new frontiers in the solar system and beyond, and serve as a testbed for technology that may one day fly in space. We have some things left. For example, how much water did we find? How is it distributed over the lunar surface? We are talking about 100 to 400 parts per million in the lunar regolith. That is 330 grams of water per cubic meter of lunar soil. This is, of course, a very small quantity, less than the one we can find in any desert here on Earth. As a comparison, the Sahara Desert has 100 times the amount of water than what SOFIA detected in the lunar soil. Despite the small amount, the discovery raises new questions about how water is created and how it persists on the harsh, airless lunar surface. Another result published by Nature makes use of the LRO, Lunar Reconnaissance Orbiter, which has been orbiting the Moon since 2009. The scientists calculated that micro-cold traps exist and could add up to 15,000 square miles of the lunar surface where ice could exist. This would mean easily accessible water. Obviously, keep in mind that we are not talking about water masses, so don't expect compact amounts of water, because we are referring to single scattered molecules that are not enough to sustain life as we know it. Over 1 million molecules of lunar soil, 300 to 400 of them are water molecules. Also, cold air doesn't exist on the Moon because the Moon doesn't have its own atmosphere. So the question now is, where does the water come from? Several forces could be at play in the delivery or creation of this water. It could be possible thanks to micrometeorite impacts. This is actually a two-phase process. First, the solar wind lets hydrogen on the surface cause a reaction with the oxygen present in the minerals, creating hydroxyl. Then when a micrometeorite impact occurs, hydroxyl would be turned to H2O. Water could be trapped in meteoritic molten glass microspheres. On Earth, we refer to them as tektites that make up regolith. Anyway, we have to say one thing. Despite the fact that lunar craters at the South Pole are very deep, they are very important to us. Do you know why? Because they are made of ancient ice that may date back from the time the Moon was formed. That is about 4 billion years ago. Thus, even if they are not easily accessible, they may preserve the conditions of the primordial solar system when our satellite was forming. I know what you are thinking. If the water was distributed all over the lunar surface, did we find it when we went there in 1969 with the Apollo 11 mission? The answer is yes. Of course, astronauts didn't see water on the Moon because they are just molecules melted in the regolith, but they brought home some lunar microsamples partially vitrified by impacts. An infrared microspectrometer detected in the vitrified portions of the absorption of around 3 micron of the OH radical, bound to a silicate matrix, and due to the presence of at least 150 parts per million of H2O. Also, the M3 Moon Mineralogy Mapper spectrometer found evidence of the presence of water even at much lower latitudes than the poles, up to plus or minus 30 degrees latitude in 2008. We discussed this new discovery on the Moon, but we have one more thing left: the Artemis mission. Before finding out more about the Artemis mission, be sure to like or dislike the video so that we can continue to improve and make these videos better for you, the viewer. Plus, be sure to subscribe to the channel, clicking the bell so that you don't miss any of our weekly videos. In Greek mythology, Artemis, named after the twin sister of Apollo, who is also the goddess of the moon and the hunt, encompasses all of our efforts to return humans to the moon, which will prepare us and propel us on to Mars. Through the Artemis program, NASA will send the first woman and next man to the moon by 2024. NASA will collaborate with commercial and international partners to establish sustainable exploration by the end of the decade. Then we will use what we learn on and around the moon to take the next giant leap, sending astronauts to Mars. They will build elements on and around the moon that allow robots and astronauts to conduct more science than ever before. For instance, the so-called Gateway will be an outpost orbiting the moon and is a critical component of NASA's Artemis program. It is a destination for astronaut expeditions and science investigations, as well as a port for deep space transportation, such landers en route to the lunar surface or spacecraft embarking to destinations beyond the moon, as written on NASA's website. Here are some Artemis's goals. 1. Find and use water and other resources needed for long-term exploration. 2. Investigate the moon, learning more about our home planet and the universe. 3. Learn how to live and work on the surface of another celestial body. 4. Prove the technologies we need before sending humans to Mars. We can say it out loud. What a time to be alive. With the 20s, we are starting a new era in space exploration. Someone said that if you want to become an astronaut, this will probably be your chance. Don't miss it. We won't be surprised if by the end of the decade there will be about 100 astronauts in space at the same time from different parts of the world. In times like this, when the world is facing a global pandemic, science gives us some prospects of hope. Being on the side of science today is being on the side of science today is being on the side of the future. Making science today means to make a group. Can you understand its power? That's all for this video. Thanks for watching, everyone. Did you hear about this discovery? What do you think about that? Do you think it will be useful to future moon missions? Let us know in the comments below. See you next time on the channel.